which is 600 minus 200, that is to say 400. So the answer will come out to be 100. The choice will be second. For the gaseous reaction, AB2 solid giving you AB gas plus B gas, if total pressure at equilibrium is 16 atmosphere, then Kp for the reaction is. For such questions, you see, on the reactant side there is no gas, means initially there was no pressure. Now when the reaction has taken place, 1 mole of AB and 1 mole of B has formed. It means the total pressure is equal to the pressure of AB, partial pressure of AB plus partial pressure of B. Since equal moles of both are being formed, it means partial pressure of each is 8 atmosphere at equilibrium. Hence, we can write Kp for this is equal to partial pressure of AB into partial pressure of B, which is 8 into 8, that is to say 64 atmosphere square. Hence, the answer will be 3. In this way, you can solve a number of questions, but do keep it in mind the physical state of the substances. If the gases are involved, then you take their partial pressure and accordingly write Kp. The value of Kp or Kc will tell you the extent of reaction. Supposing he has given you 3 or 4 cases, in which of the following the reaction will move to the maximum extent, the yield will be maximum. It means higher the value of K, greater will be the extent of reaction. Now, in this chapter, we are coming to Le-Chatelier's principle. Le-Chatelier principle says, if a reaction at equilibrium is subjected to any constraint, that is to say, change in temperature, pressure or concentration, then equilibrium will shift in a direction so as to undo the effect of that change. For example, if we are increasing the volume, then indirectly we are decreasing the pressure. So equilibrium will shift in a direction where there is the effect of lowering of pressure. Or if we increase the concentration of the reactants, then equilibrium will shift in the forward direction. If the reaction is exothermic, then low temperature will favor the reaction in the forward direction, high temperature will favor the reaction in the backward direction. Let us take an example. For the equilibrium, water solid giving you water liquid. If the pressure is increased, then, dear students, generally pressure do not affect if the gases are not involved. But here you know, water in the form of liquid has lesser volume as compared to solid. So when you apply the pressure, this equilibrium will shift in the forward direction. Hence, ice will melt. So the correct answer will be third. Supposing he says, if after equilibrium has reached, some amount of water liquid is removed, then in which direction the equilibrium will shift? Don't think that the concentration will have any effect. I have already told you concentration of pure solid or pure liquid is taken as unity. It means in this case there will be no effect of adding water in the form of ice or removing water in the form of liquid. Supposing he has given you another equilibrium reaction, A giving you B, and says the value of Kp or Kc is 10 to the power minus 3 and a catalyst is added, then what will be the value of K? Dear students, catalyst simply changes the value or simply increases the rate of forward as well as backward, but it does not change the value of K, the rate constant. Undoubtedly, in chemical kinetics, you have seen that catalyst increases the rate constant, but equilibrium constant is the ratio of rate constant of the forward and backward. So catalyst will increase the value of both to the same extent. As a result, the equilibrium constant will not be affected by catalyst. It will, supposing he says that A is gas, B is also gas, and 1 mole of A gives you 2 moles of B, and the volume of the vessel is doubled. What will be the value of equilibrium constant? Dear students, equilibrium constant is affected only by temperature, neither by the value of pressure, nor by the value of concentration terms, nor by the value of catalyst. So do keep these things in mind